All right, we're going to look at another problem to find the exponential equation that passes through these 2 points. But I want to show you a different approach, just to show you a different method that maybe some of you will like and may be useful in your future math classes as well. So again, exponential equations are in the form y equals a times b to the x. And what we're trying to do is we're trying to find a value for a, which is the starting amount, and b, which is the multiplier. What we're going to do instead of making a table is a different approach. So we're going to replace, these stand for x and y. This is also an x and a y coordinate. What we're going to do is replace the x and y in this equation with these two numbers for the points. So we'll write one equation, instead of saying y equals a times b to the x, we'll replace the y with a 2, a times b into the 0 power. Right? Our x was 0 and y is 2. So we're just going to replace that in this equation. And we're going to do the same thing with another set of points, with this other point 3 and then 32,768. So I'll write 32,768, that's my y, equals a times b to the 7. Yes? All right. And a lot of times what's helpful when we do this approach is if we stack our equations on top of each other like this. But if we start with the exponent that is higher on the top of our equations, which is not how this is set up. So let's rewrite this so the other equation with the bigger exponent is on the top. And that's just going to help us out in the next step. Okay, so we just wrote it where this 7 is bigger than 0, so that's why I put this equation on the top. What we're gonna do now is divide each part of the equation with each other. And if I do that, if I make a fraction now, this is a times b to the 7th over a times b to the 0. And what's gonna happen is those a's are the same amount on the top and bottom, so I can cancel those out, right? I can divide this side too. The 32,000 number divided turns into 16,384. And when I do that on the other side of my equation, my exponents here, just like we had an exponent of a 1 and a 1, we subtracted, that made nothing. That's why we don't have any a's. 7 minus 0 will be just b to the 7th. Okay? So now we have no more a's in here, and we have a number equals b to the 7th. To get rid of the 7th exponent power, we'll take the 7th root of both sides, which is something similar to the other process. So when I do that, take the 7th root of the 16,000 number, I'm going to get 4 actually, and I'll have a b left on the other side. So we found our multiplier right now. And what we can do is plug this back in, just like when you do elimination or substitution or equal values. We need to find the other value, the other variable, and plug this one back in to either of these two equations that we started with. I'm going to use this one. And actually, if we do that, 4 is our b value. So 4 to the 0 power, anything to the 0 power is worth 1. So really what we could have done in the beginning, we could have realized that way back in the beginning, but that's okay. So if we plug in this, my a times 1, that just turns into a right there. So our a, our starting value, is worth 2. So again, the goal was to write an equation that goes through those 2 points. So I'll put our a first, 2, times our multiplier 4 to the x. All right, so that equation would pass through those 2 points. So a new strategy for you to try out.